What is an inner product? How does it relate to quantum mechanics? And how does it benefit us? We're going to be discussing a basic and yet fundamental concept commonly used in quantum mechanics, known as inner products. Inner products are typically used to help us understand, what potential vectors exist in some vector space, and scientists commonly refer to this space as the Hilbert space. I do not fully understand the Hilbert space aside from its literal definition. I don't want to dive into it too much until I understand it in depth and it becomes a concept, because there's a big difference between understanding something as a pure definition and understanding something as a concept. Being able to use it as a concept would mean that I'm able to, apply it to real world settings, but as of right now, my definition only stems from what I've learned in this book. What I want to do in this video is conceptualize what an inner product is and how it's beneficial to us. And when you look at the mathematical model, it makes sense, but one thing I was having trouble understanding was, how can I conceptualize this to my own term? And the best way I thought of was a particle in a box. Everyone uses a heads or tails example, and when you measure something in a superposition of heads or tails, obviously it goes to either tails or heads, whatever, but what does that mean? And when you think of a particle in a box, you have this square box. It can be a big box or a little box, whatever you want, use your imagination. And inside that box is a particle moving around willy-nilly, no fucks given. At a certain time in a certain space, where will this particle or electromagnetic particle exist? Whatever you want to do to conceptualize it. And how can we guess where it exists? Because if we measure its position, we collapse the wave itself. You're unable to measure it, but how can we predict where it will exist in a superposition of all these states? Specifically, let's say we're given two sets, A and B. We would get 0 if intersecting both these sets results in 0, because that means there are no elements that these two sets don't share in common. How we can view it is, maybe A exists in some vector space and B exists in another vector space. How can we understand the relation? Let's say B is secretly the conjugate of A, which means B is some position equivalent to A, but moved over, scaled over, however you want to view it. How can we understand the relation of these two, and how can we figure out if B is secretly A? And we can use the inner product to better understand what elements lie inside A and what elements lie inside B. This takes me to my last point, because I like keeping these videos short. I'm actually a big fan of it, and we can call these sets orthonormal if taking the absolute value from distance A with respect to the origin and the absolute value of distance B with respect to the origin results in 1. The state's got to be somewhere. It's got to be somewhere between 0 and 1. You can think of it as the particle needs to exist somewhere between 0 to 100, and the probability of it existing is somewhere from 0 to 100%. If X starts at 0 and we go all the way to 100, where will this particle be? And what is the probability that it will be there? Thank you for watching. I'm concluding today's video. I'd rather keep it short. It is Saturday. I wanted to make sure I put this out there somewhere as I continue learning more and more, and maybe we'll recover the inner product once I get a whiteboard, because God knows it can be a little hard to explain things sometimes unless I'm able to draw it out. Thank you for watching. Stay learning.